This math summary focuses on number properties, including looking at prime and composite numbers and the difference between square and triangular numbers. When we're looking at prime and composite, we need to understand what those terms mean. They're different and they represent different numbers because we can actually classify numbers as whether they're prime or composite if they're whole numbers. So if we have a prime number, we're looking at numbers that only multiply, not add or subtract or divide, but multiply by themselves times 1. A perfect example is 17 because you can only make 17 if you have one group of 17 or 17 groups of 1. It's the number times 1 and that's it. Whereas composite numbers have combinations of numbers that can multiply to make that number. For example, 15. We can say one group of 15 or 15 groups of 1. We can also say 3 groups of 5 or 5 groups of 3. There's another combination that make 15, the 3 groups of 5 or 5 groups of 3. It's not just 15 groups of 1 or one group of 15. So when we have a composite number, it's composed of different combinations. Now, a different way to think about that, or a way to remember the two words and their meaning, is to think of the word prime. We have a prime minister and there's just one for the country. So it's just the number that multiplies by 1. Whereas composite, we can think of a composition in an orchestra. A composition is written for lots of instruments so that the whole orchestra can play, so that the violins and the flutes and everyone can play. That composition, it's composed of lots of instruments. So we've got combinations. It's composed of lots of different combinations that make that number. If we look at prime numbers and composite numbers, let's see if there's any sorts of patterns or rules that we can retain after we explore it. So if we think about the numbers, say, between 10 and 20, and it's good to explore a whole stack of different numbers when you're looking at prime and composite numbers. So 10, well, I know I can do 1 times 10 and 10 times 1, and I can do 2 times 5 and 5 times 2, so it would be a composite number. There's lots of combinations, but 11, it's only 1 times 11, or 11 times 1, there's only one combination. So I would say that's prime. 12, I can do 12 times 1. I can do 2 times 6. I can do 3 times 4. There's so many different ones. 12 is composite. 13, it's only 1 times 13, or 13 times 1. So 13 is prime. 14, I can do 14 times 1, but I can also do 2 times 7. So it's composite. Now, we could start to think that every odd number is prime and every even number is composite, looking at this pattern that's developing.
If this short lesson is helping, imagine what over 200 just like it could do. Clear, quick, and confidence building. They're all waiting for you on our website. Now let's get back to it.
However, when we get to the next number, we notice 15 is odd, and 15 was 1 lot of 15 and 3 lots of 5. It's got different combinations. So 15 is actually a composite number and it's an odd number. What we find is even numbers are composite numbers because we can do 2 groups of things, like 16, 2 groups of 8, like 18, 2 groups of 9. We can think of even numbers as composite, except for the number 2, because we can only do 1 group of 2 or 2 groups of 1, it's prime. But it doesn't instantly mean all of our odd numbers are prime numbers. We could have, for example, the number 27, and 27 is 3 groups of, that's right, 9. So we've got an odd number, but it's a composite number. So explore prime versus composite, thinking of what the characteristics are for each of those groups. But we can also classify and think about number properties of square and triangular numbers, and you can see visual representations of each. A square number looks like a square. It's got even rows with the same number in each row. So for example, 3 squared is 3 rows of 3. It creates a square, an array of dots that makes a square. And we would say 3 squared is 3 rows of 3. It's the number times itself. It makes 9. So 5 squared would be 5 rows of 5, or 25. 8 squared, 8 rows of 8, or 64. 10 squared would be 10 rows of 10, or 100. 12 squared would be 12 rows of 12, or 144. So we can explore all sorts of different numbers that are squared numbers, but triangular numbers are different again. We create a triangle when we have 1, 2, 3. So 3 is a triangular number. We add another row to make another triangle, a larger triangle, and we have 6. 6 is a triangular number. And then we add 4 here. So 10 is a triangular number. We can keep exploring all the sorts of different triangular numbers by adding another row and counting up how many altogether. Different to squared numbers. So there's classifying numbers for prime and composite, as well as squared and triangular numbers.